My name is Aimee Barciauskas, and I'm with the Nature for Development team at the United Nations Development Program. So this is my first time at an IMAGERY symposium, and it's been a wonderful day so far. It's really great to be able to engage with this collaborative community. And so at UNDP, we work on the ground in over 170 countries to support national and local efforts towards conservation and sustainable development. So EOE's mission to build networks and capacity across diverse knowledge communities to improve decision-making for sustainable development is really right in line with what we do, and it's so interesting to be able to see the various ways different groups and initiatives present here are taking approaches to sustainable development. So this afternoon's session is really getting at this core of how to transform data into action for sustainable development. And our panel brings together a diverse range of perspectives from community-based OpenStreetMapping to the large-scale African Data Cube initiative. So without further ado, I'd like to introduce the chair for the panel, Francis Gassert, who's the Data for Impact lead at World Resources Institute. So thank you so much and enjoy the session.
Great, thank you, Annie. So Davis is right here. Okay, great. So we have three great panels today, bringing together different perspectives and how they found impact with data. Davis Adieno, Regional Director for Africa at the Global Partnership for Sustainable Development Data, who has worked extensively with governments and civil society on large-scale projects such as the Africa Regional Data Cube. Rebecca Firth, Community and Partnerships Manager at the Humanitarian OpenStreetMap team. Rebecca grows the community of grassroots contributors who help create the largest open source mapping project in the world. And Aimee Barciauskas, a data engineer at Development Seed. Aimee works on making NASA's enormous data stream accessible on the cloud, and leads a chapter of data science volunteers at DataKind DC. In today's session, each of our panelists will give a short presentation on their work, and then we'll go into a panel discussion on what they've learned in turning information into action. We'll also reserve time at the end of the session for all of you to ask questions of our panelists. Perhaps I can start by turning it over to Davis.
Great. Thank you so much, Francis. Really fantastic being here. As you've heard, my name is Davis Adieno. I work for the Global Partnership for Sustainable Development Data based in Nairobi, Kenya, that's supporting its regional strategy in Africa. Maybe quickly just to mention the partnership really is a multi-stakeholder global network that brings together over 330 members. Organizations really focused on leveraging data to figure out how we can really support the delivery of the SDGs. But we are also cognizant that at the country level, at the regional level, there are other development agendas. So it's sustainable development broadly, really, looking at how data can be prioritized and how it can facilitate collaboration in a way that gives us meaningful insights for the delivery of the SDGs. Within the context of the Sustainable Development Goals, really our approach is thinking about how multi-stakeholder data ecosystems can bring together governments, private sector, civil society, research, academia, and all these different other data communities. Often you'll hear about the National Statistical System, which is what is traditionally known to drive the statistics agenda at the national level. But within the context of the data revolution, we are talking about doing things differently. In a sense, opening up the National Statistical System or expanding it in a way that then allows other data communities to come in, ultimately with the objective of collaborating, complementing, filling data gaps, and finding ways in which we can catalyze partnerships that tackle specific data challenges at the national level or at the subnational level. For us, I think what's important, and of course, our membership really is comprised of governments. In Africa, we have Kenya, we have Tanzania, we have Sierra Leone, we have Ghana, Senegal, Cote d'Ivoire is coming on board. In Latin America, we have Colombia, Costa Rica just joined this year, Mexico, and many others. So the idea really is to think about in those countries, how do we engage with government and national statistical offices, and at the highest level, the offices of the president, the deputy president, the prime ministers, to catalyze political goodwill and create an enabling environment that promotes data for sustainable development, and then figure out ways in which we can collaborate at the more technical level to think about, now that we have an enabling environment, how does the technical, at the more thematic level, in agriculture, in health, in education, environment, and other issues that people are actively working on, how do we then catalyze data collaboratives that allow organizations, individuals to complement and leverage the resources they have, the skills that they have, the networks that they may have, and find innovative solutions that allow them, to tackle the day-to-day challenges that face different organizations. So when you're looking at harnessing the data revolution, of course, our role as the global partnership is more of a broker, so to speak. We facilitate, we convene, we connect, we catalyze, and allow all these other data communities to work together in ways. And often we find that at the country level, these are institutions that often don't talk to each other or don't collaborate for one reason or another. It may be either political dynamics, it could be competition for resources, or it could be just the institutional arrangements don't allow them to work together. So for us, the thing is, how do you break down those barriers that then allow these institutions, first of all, to just sit on the table and start talking? And often when they do that, you realize some of them saying, oh yeah, we've been collecting data in this area, and others will tell you, yes, we've been collecting similar data in this area. Why don't you share your data, because it seems to be, more up to date, it seems to be more relevant to us. There are certain indicators that you're collecting data on and we are collecting data on. How can we collaborate to ensure that we don't duplicate? So looking at all those different data communities and how they can come together to think about innovative solutions, and then feed that information into the national, the regional, and global discussions, like what we are doing right now through the World Data Forum. And of course, tomorrow we'll be having a session here that will be looking at Earth observations data. So some of our country partners will be speaking about the more concrete things they're actually doing at the national level. But I wanted to give just a practical example of how we're doing this. So in May this year, we launched the Africa Regional Data Cube, which really aims to provide analytically ready satellite data across decades to support delivery of sustainable development in Africa. How does it work? What we've done is to think about a small infrastructure that can aggregate data, satellite data that's free and open source. But we know the challenges with satellite data. It's whereas it's open source, it's easily available. If you look at African countries, issues around internet processing of some of this data makes it a challenge for a number of governments to access it. So together with NASA, the Committee on Earth Observations, the Group on Earth Observations, European Space Agency, the government of Kenya, and I'm happy that the Kenya National Space Agency is here. Strathmore University is one of the partners. They're also in the room. We came together to launch the Africa Regional Data Cube that looks at data for 5 countries initially. So this is Ghana, Kenya, Senegal, Sierra Leone, and Tanzania. It is a response to a demand from the country level. we were hearing that there are certain gaps in agriculture, and there are gaps in water. Countries are conducting agriculture. They're planning to conduct agricultural surveys. There are gaps when it comes to issues around urbanization, illegal mining. All those are issues that come at the, from the country level. And one of the ways we thought we could respond to that demand is to tap into this open source satellite imagery, and together with NASA and all these other partners that I've mentioned, facilitate access, easy access to analytically ready data, but also think about how algorithms and methodologies and tools that have been developed in other countries, such as Australia, Colombia, Switzerland, can then be deployed and made available to these countries to apply. The way it works is a fairly simple model. Amazon Web Services, one of our core partners, is providing the storage. Through S3 or simple storage, up to 13 to 23 terabytes. And through the Africa Regional Data Cube, NASA, Strathmore, East Africa Data Center, and others are responsible for managing that infrastructure. So downloading the data, basically managing the infrastructure itself in terms of new data ingestion, and managing a web-based user interface. And then each of the countries has a computing instance or channel that allows them to tap into the cloud and access the data. And of course, what we're doing is to provide 17 years, up to 17 years of data, of Landsat data initially. In the next 6 months, we'll be providing Sentinel-1 and 2 data and making it available to these countries. So, and then we have Jupyter notebooks, which is what the partners now use to run the analysis. And of course, the Amazon Web Credits then allow the coordinating agencies within the countries to distribute these credits that allows then multiple agencies within the countries to access the data. And then what we hope to do is to build other data communities around specific thematic areas. So some of the algorithms we have range from cloud-free mosaics, spectral indices, land classifications, water, land change. So it's very easy for government officials, and some of the stories we are hearing is recently we just had a training for over 30 government institutions, actually 2 weeks ago in Tanzania, and one of the participants said, one of the analysis that was done in just preparing, they gave a geo coordinates, and this was processed within 10-15 minutes, and he was really shocked because he said what you've just done in 10 to 15 minutes is actually work I would have done in 6 months in just preparing the data, not even the analysis, because by the time you get the satellite imagery, you want to eliminate the clouds, then you want to stack and then look at the geo coordinates. Like that process itself is so tedious and takes a lot of time. So that's how the infrastructure is making it easy. So they can just run the algorithms, look at the geo coordinates and run the analysis and get certain images. So we're training them to use the infrastructure and interpret some of the images. So because it's not enough to make the data available. The analysis and the outputs of that should be packaged in a way that then makes it easily accessible to policymakers, for example. So if you present an image, what does it actually mean? So this is what we saw in 2014 or 2004. This is 2018. What's the difference? And what does that actually mean in terms of the policy discourse? I'll skip the timelines because of time, but really what we hope to do together with Geoscience Australia and all those partners that I've mentioned, we are thinking about scaling this up across the entire continent to make it available to all the different countries. And the way we hope to do this is by packaging the lessons of the institutional arrangements that we're putting in place right now, and thinking through some of the challenges that we're experiencing, because it's not all smooth. Sometimes it's slow, the infrastructure, sometimes the data is not applicable in certain sectors. So it's important to learn from the small scale and then document that in a way that then allows us to improve the infrastructure, but also make the outputs and the products that come out of that more relevant to more countries. So this is just an example. of what we're seeing. Tanzania National Bureau of Statistics provided geo-coordinates for a very small area called East Chenene Forest. And what they wanted to see was the level of, what has happened, in terms of urbanization and encroachment into the forest area. And just by applying the PYCC land change algorithm, what we saw was that the result of the analysis compared very well to the Global Forest Watch results, just using Landsat and a very simple algorithm. We could see that with this data, you can actually run some analysis that allows you to see at the very basic level what has happened over time. And it's free and open source. So making it available to governments then becomes a critical resource. This is urbanization in Freetown. That was year 2000, and now by the year 2017. So running analysis based on the NDBI index through the Africa Regional Data Cube, we could see that urban extent has grown by 11.4% over the last 10 years. So interpreting these images and presenting these kinds of findings, initially, it sort of hits you hard as a policymaker. And the mayor of Freetown is actually interested in this. And we recently just held a hackathon where some developers are working on very practical solutions around urban waste and thinking through how infrastructure development can be improved in ways that are more sustainable. Illegal mining on the Nkobra River in Ghana. This was done by the Ghana Statistical Service. Actually, in the year 2000, you could see the image on your far left, and the year 2017. Now, it's very interesting. If you look at the Google Earth image 2017, it shows the known locations of illegal mining by government, as in that's what they know. The data on the ground is showing them there are 3 different locations where illegal mining is happening. But when you run the satellite imagery and you can see the pink, the pink spots, what they suddenly realize is that the extent of the illegal mining was much more than what they actually were, the data and the information they had on the ground. So what this does, it pinpoints hotspots, which then warrant further investigation by government officials, which means that you're much more targeted, you're much more efficient in terms of allocating resources, and you're you're in a better position to coordinate different government agencies that are investigating the illegal mining. So that's the value of this initiative. I'll just quickly say in terms of learning, the infrastructure, the data, the tools are great, but what we are learning is that the politics within the country can play a very significant role in determining whether these kinds of initiatives succeed or not. So what we've done is to think about national coordinating mechanisms by government first, and then through those national coordinating mechanisms, create awareness, and then figure out how do we best help the countries identify priorities, because not everything can be done. So the different agencies sit together, then say, okay, let's try with illegal mining, let's try with urbanization, let's look at water extent and agriculture. So in all the 5 countries, we are seeing priorities vary to a large extent, depending on what interest the government has. And then we're also learning it's a step-by-step process. So you cannot deploy the infrastructure and say, oh, okay, here is the Africa Regional Data Cube, silver bullet to all your problems. People want to, first of all, understand, what exactly is it? What is the downside? You're offering this for free. Even if it's for free, there's no such thing as a free lunch. So what exactly is your agenda? So people want to understand what is it that you really have in mind as you deliver this. So that process in itself, just building trust, takes time. Whether you have good intentions, there's always those dynamics that play out that I think are important. And then sustained capacity development. It's not enough to go and launch the product. We initially did a training in Nairobi, and Strathmore University really provided their wonderful facilities for that. But we learned that even after the training, it was still not enough, even for the participants. 3 days of training. So what we've done is to structure virtual trainings in the different countries, and we are doing this systematically. Almost every month there is a virtual training happening, and then NASA have made themselves available to respond to any queries. So there is a sustained process of capacity strengthening that has to happen with these kinds of initiatives. And then it may not apply to all. We currently have 30 meters of resolution of the data. Should I be wrapping up? Okay. Yeah, so it may not apply to all areas, but there's some areas that are really good. And of course, you learn as you move. And then combining central data and other data sources yields optimum results. And I'm glad Rebecca is here, because she's going to talk about how mapping, for example, and layering maps on this kind of data can actually enhance, and make the data richer for presentation. So it takes time, takes patience, and it can't work without solid partnerships. We are learning that the more partnerships you have, the more structured ways of connecting and engaging, the better you are. And of course, the demand is there, but what we need is to figure out how we can harness that demand in a more coordinated way. Thank you very much.
So information to action. This session is all about how do we use data to drive decision making. And I'm going to start by talking a little bit about Development Seed. That's the organization that I work for. The company I work for is Development Seed. We're a team of engineers and designers located across the globe. And we are working with data and tools such as machine learning and satellite imagery to build solutions to the world's toughest development challenges. So we're both building infrastructure to store data, as well as building tools to help understand that data. So why is open data important? So in addition to open data, which I think everybody here can understand why open data is important, we also advocate for open source and open methodologies. We find that this strategy is really powerful because it enables people to leverage the data and the methodologies that we've implemented and run with them. So when we can't, when we're not the local experts on a problem, people have access to the data and the tools and the methodologies that we've come up with to develop local solutions to problems. So just to repeat this point, we believe in reusing existing data or tools where they already exist and contributing back to these sources. So infrastructure tools and platforms like OpenStreetMap, we really see as being the driver of scalable solutions. So I'm going to talk about a couple of our projects and the lessons that we've learned from them. So the first project I'm going to talk about is mapping the high voltage grid in developing countries. So this project is a story about human-assisted machine learning and the power that comes out of combining machine learning methods and open data with human mappers. So the problem we were trying to solve with this project is providing data to support infrastructure planning. High voltage line is really expensive. Has been quoted as up to $1 million per kilometer. And previous data on the high voltage grid was poor or non-existent. So this is an image of what some high voltage grid data looked like prior to our project. So this data is good. It's good to have some data, but you can see that there's a lot of data missing, and we can do better than this. So what did we do? We basically paired the power of machine learning with human mappers. So we had human mappers go in, identify high voltage towers. We used that to train a machine learning model that was able to expand that our target training area, expand the prediction over entire countries, right? So the machine learning model was able to predict where the high voltage towers were going to be across much larger swaths of land. Using these machine learning predictions, we were able to go in and create an overlay of a map that identified where our machine learning model had predicted high probability of the high voltage grid being. That was used by the human mappers to go back and actually trace the high voltage line, and that data was contributed back to OpenStreetMap. So we were able to produce high voltage grid line data back to the open data platform. So this is an image of what the machine learning model produced. Basically, all of these little red squares that you see are where our machine learning model predicted a high probability of high voltage line, and you can see very clearly there's a very obvious line going through the middle of this country. This is a animation of the actual human mappers working. This is in real time. This isn't sped up. These machine learning models enabled the mappers to do their work 30 times faster than previous. And then this is an animation of the OSM data on the high voltage grid map in Pakistan before and after our project. So all that data was what we generated. So this was a successful project. However, there were some limitations. And one of the things that we learned from this project is that the diversity in our training set was often insufficient. So if we had trained on one terrain in Pakistan, if we tried to expand the machine learning model outside of that type of terrain, our model performed really poorly. So we need to work towards enabling users to download smaller and thus more images, creating a more diverse training set. And we also need to validate our training data as being diverse enough for the prediction targets. Yes, and then this is a blog post that was written by my colleague Drew Bollinger, Geodiversity for Better Machine Learning. So if you're interested in this topic of diversity in machine learning, then this is a great resource for some of the tools to create diverse training sets. So stepping back from machine learning, I'm going to talk about an open data platform called OpenAQ, which stands for Open Air Quality. So OpenAQ is a project I've worked with both at DataKind as a volunteer and at Development Seed as an engineer. So the problem that DataKind is trying to solve is that poor air quality is the cause of 1 out of 8 deaths worldwide. And in order to empower people to advocate for air quality regulation, we need to provide open data for them to analyze and provide, sort of empower the advocates of air quality policy to go talk to their legislators. So OpenAQ is a nonprofit organization, and they have aggregated air quality from different sources across the globe. And what they're doing is really powerful for a lot of reasons, but the two that I find the most compelling is that they are storing data uniformly. So they're taking data from 63 different data sources across the globe in data formats that is heterogeneous and ephemeral, and they are storing it for long-term access in a uniform way. So as I mentioned before, they're taking this data from 63 different sources, and they're storing it for the long term. So data that is posted once on a website and taken down the next day, they're collecting that data daily so that it's stored long term and accessible by users for analysis. In addition to those two things, storing data uniformly and storing data long term, they are following all the other sort of best practices that I came across in Project Open Data, which is an initiative of the White House to it's an initiative of the White House to basically help US-based agencies to basically produce their open data in a way. So open data is not enough on its own, right? You can't just put open data out there and say, I'm done, I did it. You need to also make sure that your data is accessible, meaning that it's machine readable, it's described, it's reusable, it's complete, it's timely, and it's managed post-release. So there's somebody available to actually answer questions about it. So if you are somebody that is interested in opening up data, I do think that Project Open Data's principles and other resources are a useful starting point. So the other thing that makes OpenAQ really great is this sense of community. So one of the things that I mentioned earlier in the presentation is about contributing back, right? So when you're producing open data and you're working on open tools, one of the things that makes that powerful is that it enables people to take that data and take those tools and do things that you couldn't have thought of. So OpenAQ really is representative of this, and they really actually feature all these projects that people are taking the air quality data that they're producing and doing things that OpenAQ as an organization could never think of themselves. So for OpenAQ, data coverage is still a problem. We still don't have air quality data from all over the world. We still have a problem with actually not just air inequality, but data inequality. And I've also learned, especially as a volunteer, that it's challenging to get the right stakeholders together. I think even though we've only been at this forum for, I don't know, 8 hours or so, every session that I've been a part of is talking about getting the right people in the room and being able to communicate in order to actually make effective change. And that's something I've definitely seen with air quality, getting data scientists, domain experts, policymakers, and communicators all in the room, willing to talk to each other and willing to talk to each other long-term and make change. So finally, the last project that I'm going to talk about is a project called MAP, which stands for the Multi-Mission Analysis Platform. This is a collaboration between NASA and the European Space Agency, ESA. And this project actually really highlights a lot of the themes that Davis was talking about in terms of having people share data and share platforms. So the challenge is that we're getting a lot of new data from satellites coming in the next 5 years. And in order to leverage the power of this data and not duplicate work, we want to create a platform for scientists to share and collaborate on the data and the algorithms. And that's the MAP project that we're currently working on. So this is the growth in data just within NASA's Earth observation data in the next 5 years. It's going to be growing by about 10 times its current volume. So we're building a shared platform. This shared platform is going to share data, share tools and algorithms, especially now in the case that you can't download or analyze all of this data on your own. You really need cloud resources, really strong, large amount of computing resources and storage resources in order to fully leverage the power of this data, as well as not to duplicate analysis. We want to build a shared platform and versioning algorithms and all that stuff that Davis touched on as well with the Africa Data Cube. So these are just my resources on the things that I mentioned. So thanks.
Hi, so I'm Rebecca Firth and I'm working with Humanitarian OpenStreetMap team. And just wanted to talk a little bit around how we engage communities and volunteers on this kind of data interaction piece. So essentially, how can we aid an individual anywhere in the world with any type of background to create data that's genuinely useful to a formal data user who might be kind of part of a government department or an NGO or someone who's trying to kind of do something really meaningful with that data. Often those two people are actors who wouldn't usually talk to each other. So, 17-year-old kids using an Android phone in an informal area are not normally working in the same project as their government. And so what we do is kind of try to bring those together through OpenStreetMap and open mapping apps. So these are just a few photos of some of the faces that kind of make up the people who do this. There's 4 million editors to OpenStreetMap. But for humanitarian specific projects, there's kind of 150,000 people who have really given quite a lot of time and effort to actually fill in the maps in places that are particularly vulnerable, experiencing an active crisis, things like that. So just a quick few words on how this works. This is a really, really simple example of how someone might use satellite imagery to map buildings. Mapping sounds really complicated, and it's literally just drawing in the tools that we kind of tend to use to create quite a crude base map. So you see a small square of satellite imagery, and you just draw over the buildings and the roads that you see. It's really one of those kind of anyone can do it activities. And this is coordinated via a tool called the Tasking Manager, which essentially just enables a bunch of people to do this all at once. So this shape that you see here is the area we want to be mapped. But if you want to do mapping and you want to do mapping, then you'd both kind of overlap each other a lot. If you weren't doing it in a tool like this, that means you're all working on kind of separate squares. And then we have a few kind of phases of validation, which are really important, obviously, in terms of ensuring quality and confidence in the information. So really simple things like making sure the road that you drew coming out of one square is actually connecting to the one that someone else drew going into another one. And so that's the kind of remote phase. And then there's a whole bunch of activities which happen in country. These can be done by community members, volunteers, people working with the organisations we're working with. So, for example, if you have a group of community health workers running a programme, they're doing this programme anyway, they're capturing data anyway, but they're often doing it in a kind of paper form or a format that isn't like shareable or isn't easy to keep up to date. And through OSM, they can kind of still be doing that exact same job, but creating something that is now sort of really useful to the Ministry of Health or something like that. So we have, this is our kind of tagline for all of our field programs, which is local people, local tools, and just add knowledge. This is the way that we make our programs sustainable. So we're not kind of providing a huge number of expensive devices that aren't available in country, or a huge bunch of people who have a very specialized skill set that isn't possible to transfer to other people. This is like people who live in an area using the phone that they already own, but with an extra app on it that they can now use to create this data. Also makes training quite a lot easier. 5 years ago, we were doing this sort of thing in Africa with GPS devices, for example, which aren't really a native tech. It's a lot easier to train someone to use an app on their own phone than it is to use this kind of device that they've never seen before. And it also means that once we leave, they can kind of continue doing that. Obviously, the kind of data interaction point of this is, once people can actually see the benefit to them of having put something on the map. I'll share a project which is working on that in a second. Then they're much more likely to do it when the barrier to them to do that is really low. So I'm just going to share one example, which is based in Dar es Salaam in Tanzania. Several people here, I'm sure, working in the kind of Tanzanian context. But just for those that aren't, this is the fastest growing city in Africa with over 6 million inhabitants. And estimations vary, but around 60 to 80% of the city which has grown unplanned and obviously is experiencing various issues kind of associated with that, like localized flash flooding. As a world, we have particularly bad knowledge of flash flooding because it's only really captured in like media and things like that. And if that media is not covering these informal areas, then it's typically not recorded particularly well. And there's kind of a lack of access to basic services which really exacerbate that, like kind of waste removal and things like that. If kind of there's no waste removal, then often the waste ends up in the drainage and the waterways, which means you're even more likely to have flash flooding. So what we're doing is trying to train students like these two 18-year-old people in this photo here to create data at a scale and quality that is significantly better than anything that was kind of available before and is really democratized in the process. So mapping especially is something that used to be very elite, very expensive. You need kind of multiple degrees and some proprietary software and a whole lot of training to be able to participate in it. And we really believe that that's not sustainable or possible in a lot of these contexts. So how can we make it possible through better tools for people like this to create that information? Anyone who's been in informal neighborhoods in Dar knows that some of the drainage is kind of a complete absurdity. Things that kind of appear more to be like a bath than a drain. And these kids are kind of walking around Dar and creating a map of that structure, understanding where blockages are, things like that, and understanding where, for example, sections of drain don't connect to each other. So really simple things. They use rulers like this one that they make themselves. They stand next to a drain, they press go, they walk along the length of it, they press stop, and they type in the width. So it's really simple. They also kind of capture a whole bunch of other things, including what I think is the world's largest collection of drain photographs. but I doubt that we'll be making an exhibition anytime soon. And yeah, these are just kind of really simple program examples of the people that are working on that. So what does that mean when you actually try to use it? We've trialed a few methodologies in terms of working with communities. The one on the left-hand side is what happens when you ask at community meetings people to identify localized flooding. So you can see a really strong pattern here. However, it is it's pretty distinct. The one on the right-hand side is what happens when you train a whole bunch of community members to go out on the streets they live on and get that information. There's quite a difference here. And one of the reasons I think that is that it's quite easy to say sort of over there, it's flooding. And kind of in a community meeting type session, that sort of kind of focus group and kind of crowd mentality can really come through. Whereas when you have sort of one person walking down the street that they actually live on and they say to their neighbor, hey, was there flooding in your house? And they say no, they can be like, oh, well, you know, my house flooded and I live next door, so it's probably likely yours did as well. And they can quite easily get really quite high quality information, the same way that, you know, if I personally walk up to a house in an informal neighborhood and say, what are your experiences of flooding? The question those people are hearing is, I'm thinking of bulldozing your house, not, you know, I have a genuine interest in water and drainage in your area. So yeah, really interesting. You can see some kind of very localized spots here as well. So one just quick thing and then I'll wrap up for questions. All this data is open source, but we also kind of are very passionate and some parts that Aimee touched on as well around it being openly editable. So it's kind of one thing for your data to be open source, but actually in terms of really sustaining it long term, especially if, you know, you as a group don't survive, then open editing of that data is really important. And it's all available via a range of different platforms, but probably the easiest for most people being HDX. And yeah, let me know if anyone has any questions on particular types of data that might be available or locations. And we'll stop there for questions.
Okay. So my first question for the panel is to talk a little bit about who they're trying to reach with their projects and how do they assess what tools and information their audience need and how best to deliver it. So perhaps I can put this to Davis first. So with the Africa Regional Data Cube, who within these countries are you trying to reach? How do you decide how to prepare the imagery that you're preparing and what algorithms to include?
Thanks, Francis. Really, being a global network, like I mentioned earlier, our reach is global, which means that we are fairly ambitious in terms of who we are trying to reach. Obviously, at that level, we have governments who are members of the global partnership. We have private sector entities that are members of the global partnership. We have civil society organizations, right from international NGOs to local level organizations. But primarily, we are driven by the belief that data should be driving sustainable development at all levels. And that for us really means that we have a diversity of, quite diverse range of stakeholders that we are trying to reach. You know, and the idea really is to think about who are the change makers within those data communities. So if it's a local level civil society organization that's actually delivering on a certain innovative way, you know, they become our target audience in terms of connecting them to others who may either support or take up some of the products that they have. If it's within governments, there are two different levels. You know, you have the political level where we want the ministers and politicians and the presidents and the vice presidents really to prioritize data. And then at the second level, we have the technical group, which is the technocrats within ministries, departments, and agencies who do the day-to-day work. So a meeting point between those two means that on the one hand, you have an enabling environment, and on the second hand, that enabling environment is catalyzing certain amounts of action. Now, to be more specific, for the Africa Regional Data Cube, the primary targets are governments. And within governments is the ministries that will find value in Earth observation data. So mostly this tend to be either the Ministry of Environment, what you observed is the Ministry of Lands. In Kenya, for example, the Kenya National Space Agency, the Ministry of Agriculture. So these institutions that over time have been certainly using Earth observations data on satellite imagery for one purpose or the other, but face certain constraints. So making this available to them facilitates easy access and, of course, facilitates the sharing of algorithms like I presented earlier. So, but beyond government, we know that there's value in building other data communities around the thematic, especially at the thematic level, because you find there are civil society organizations that are working on urbanization or illegal mining or agriculture. So at the thematic level, what we're trying to do is to build data collaboratives that bring together those other data communities to be part and parcel of this. And why we're doing that is broadly the recognition that a lot of innovation comes outside of government. Governments tend to stick to a certain script because of a job they need to deliver, either capacity constraints or resource constraints. But we have innovation hubs, for example. We have tech hubs. We have civil society organizations that are already, collecting different types of data through citizen-generated data. So a meeting point is basically deal with the government infrastructure that creates an enabling environment and framework and looks at the policy and legal issues, and then bring in other stakeholders who are also interested, for example, researchers in academia who are really interested in finding innovative ways of using the products that come out of the Africa Regional Data Cube. So, not exactly a straight answer, but it gives you a fairly good idea of the complexity and the dynamic way in which you need to approach these kinds of initiatives.
Great, thank you. So, Rebecca, I'm going to ask you a similar question. So I was really struck by your community meeting versus neighborhood mapping example in the mapping drainage and flooding in Dar es Salaam. So when you're going out to engage with community members, how do you figure out what tools they need to be able to produce useful data?
So I think there's kind of two questions there. What tools they need for us is really simple. Like often it's things like rulers and a phone with an app that we've set up to configure in a particular way. What's generally more important is like what data is actually relevant in that context. And that's something we find really changes when you involve the community in it. So for example, in Tanzania, there's huge numbers of programs running for many years around collecting data, and we were part of those. And it was genuinely only this year that for the first time ever, the smallest administrative boundary in Tanzania, which is called Ashina, was ever mapped. So Ashina is like 10 to 15 houses in one particular group, and it critically is normally the name that people give when they actually go into hospital for something and they're giving their address, which for anyone working in medical records, like the address field often is just like random data field, it's completely incomparable, the information that's in that field, which means it's really hard to do things like if you're trying to respond to malnutrition. Like typically malnutrition is associated with bad water. So if I can know where all the kids that are coming from who have malnutrition, I can do something about the water in that area. But I can't do that if all I have is this random kind of data column in place of address. So kind of understanding from the community members that actually the place they identify with themselves as where they come from, being that Shina means you can map it, and then you can actually do something about this problem. One of the things we kind of have sort of started to talk about with OpenStreetMap is it's because you can tag kind of multiple names for the same place or multiple different scales of a place, then you actually enable someone to talk about where they've come from in their own language, and then someone else in like another country using a totally different system of understanding to still be able to understand that where that is, so that they can, like, you know, in our world, I guess, send them a taxi or a pizza, but in, you know, many other places actually like send an ambulance. And so yeah, we think about more about like what information is critical to that exact locality than kind of tool-based really.
Yeah, that's great. That's really interesting and great perspective to have. So, Aimee, you spoke a lot about the importance of open source and open data, and there's a lot of principles that go into these words. Often data creators don't necessarily know which standards to follow, and I think each of the projects that you mentioned, the mapping the electrical grid, the open air quality, and the MAP project, follow slightly different standards. How do you decide which of these to invest time into?
Yeah, so for open air quality, they've created their own standard, like they've created their own way of standardizing air quality data. And sometimes that is what is necessary when those standards don't exist. In the satellite imagery space, which is what the MAP project is using, that is a much busier space. So within NASA, they have their own metadata standard called, well, the tool is called the Common Metadata Repository. ESA, European Space Agency, in Europe, they have their own metadata standards. Within Development Seed, we're trying to advocate for another standard called STAC, and that's something that the principles behind that are more focused on open source and discoverability of data than maybe some of the existing tools that are out there. But I think your question is also about what are the guiding principles when actually picking those standards. And I think discoverability, for me, discoverability is the most important one. So how do people understand how to interpret the data? Yeah, does that answer your question?
Yeah. Maybe I can also ask, who are you trying to, so perhaps it's different for each of these projects, or it probably is absolutely different for each of these projects, but maybe with OpenAP, who are you trying to reach with the data that you're putting out, and how does that affect the choices that you make?
Yeah, I think a lot of different communities. So the two that come to mind are data journalists or air quality advocates. And then secondarily is like actually citizens on the ground. So people that live in communities with poor air quality or air quality issues. We want to build tools for them to easily understand how the environment that they're living in is dangerous.
Great, thank you. Davis, I have a second question for you. Could you share a story of a mistake that you've made, perhaps a misplaced assumption, and what you learned from it in one of your data projects?
Well, there could be a number of stories, but you got me there. Let me think which one will be shorter. I mean, on the Africa Regional Data, just 2 weeks ago, in partnership with the Tanzania National Bureau of Statistics and NASA, we conducted a virtual training over 4 days for 30 government officials from different institutions. And after the training, a couple of products were shared, and the head of GIS at the National Bureau of Statistics took some of these products to the Minister of Environment. And he demonstrated, he showed him the products, and then he showed him how, Tanzania is actually accessing the data and developing these products. And the minister was blown away. In Africa, it's quite difficult to get the attention of a minister, let alone secure an appointment. And what the minister actually said, and this is 2 weeks ago, is that for the next virtual training that NASA and Tanzania National Bureau of Statistics are going to conduct, which is in November, he wants to personally attend the entire training. So this is just an example of how he was super excited. He was, we didn't know we can tap into this kind of resource. Actually want to come and learn how I can actually use the data cube. So this is the minister saying that. And I think for us, it just demonstrates how important and how important it is sometimes to expose the resources that are available out there to government officials, especially if you're adding value and processing the data and making it easier for them to access it, and you're not charging anything. So it's free and it's open source. So I mean, for us, that's just one example among many.
Great, thanks. This same question to you, Rebecca. Can you share a story of a mistake you've made and what you learned from it?
I think rather than the kind of specific mistake, I would more talk about like assumptions which just evolved a lot over time. So one thing I think personally in like community mapping space that we've really learned is that provision of equipment at the individual level does not work. You are far better off having a community member whose job it is to find 10 new community members with their existing phones to use to contribute to a tool that day than you are to give that person a piece of equipment and expect that long term it will be used for that project. There's so many different reasons around that, I think a lot of which are probably relatively obvious. But we've had programs in kind of, for example, the one I spoke about in Tanzania for several years now, which used to be based on like that individual community member creating the map, and actually now it's that community member every day must recruit 5 new people to join, which means they need to tell them about the project. That person needs to have a smartphone with a decent enough GPS, which probably means you need to ask 10 people for everyone that's actually going to kind of be able to meet those requirements. And their role has completely changed from creating a map to chatting to 50 people and getting 10 of them on board. That kind of scalability and the impact of how much things change when people kind of use their own equipment versus when you provide it is huge. Relevant at so many other different scales. Like we've tried some really small scale innovations in response to that in other countries where people are, for example, stipended for their time. I could give you, I don't know, $5 for participating, or I could give you $2 for participating, $2 for bringing your own phone, $1 for something else, and then suddenly everyone has got some equipment that they can use, and you don't need to provide it yourself. And so we kind of have tried like a lot of very, very small scale things to try to resolve this issue of access to devices and things, but it's been made so much easier by increasing smartphone penetration in the last few years. And then on a practical sense, I also think that when it comes to actually running these field programs, there's a huge benefit in like all of our team actually now like have a lot of experience in the context they're trying to work in, which is really important because I spent the last few weeks in Guatemala working on a field program, and we were blocked 7 out of 10 days by the fact that there was a couple of cyclones meeting in the middle, which meant that you can't really go and do anything. And like that kind of thing happens just all the time in all these locations, and for us it's just really important that when we're working in a context we're hyper aware of things like that, because it's not a frustration, like that's just life. You just need to have a plan for your project so that you can actually deal with it, and so that's kind of increasingly important to us in a practical sense, to be like genuinely knowing the places that we're working.
Wonderful, thank you so much for that. Same question to you. Can you share a story of a mistake you've made or a misplaced assumption?
Yeah, the story that comes to mind is particular to software development, because that's what I do, but I think it's extensible to a lot of the things that we're talking about. So it's just when you don't consider your users in developing a tool. So we had a project where basically it was a prototype, and the prototype was very successful. However, when we tried to transition it into production, we did it in a way that didn't put the users first. So we still didn't maintain sort of the iterative cycle of development that we like to practice in Agile, where you actually go and you talk, you put something in front of the users first, and you make sure that they have a good user experience, and then you iterate on that with additional features. Instead, it just sort of became, it's just sort of a monolith that's hard for a lot of the users to actually work with or understand. I think the other lesson that really has come out of that experience for me is, another sort of obvious thing, but good documentation, right? So the importance of good usability and good documentation, and in a development sense, good documentation, when it comes to software development, good documentation is really the good user experience, so being able to understand the software and how to implement it. But I think that actually does tie back to a lot of things that we're talking about, because they are tools. So we're talking about building tools like African Data Cube, and the multi-mission analysis platform that are tools, and if they're not well documented and if you don't have examples, if you don't have a way of explaining why you built it the way you built it, people they're not gonna be able to work with it, and they're not going to want to, so yeah.
Great, thanks a lot. I think we may be running close to the end of time, so maybe we can open it up for audience questions. We can take a few questions, so please just let me know if you have a question.
Hi, David Jensen, UN Environment. And I missed the first part of the presentation, so I apologize if you covered this, but I'm wondering if you have any lessons to share about your business model and about how to generate business models that finance public goods. And yeah, basically how the cost recovery, or how you can basically sustain your product going forward. Thank you.
And was that for a specific panelist or just in general?
Just in general, the business model is my biggest challenge right now in terms of generating this kind of platform, so I'm just curious if there's any lessons from any panelists.
I have a short answer, which is just having the right partners and the right relationships. So we have good relationships, I think, with the World Bank, NASA, WRI, so that enables us to do the work that we really care about.
But I agree, but what about, let's get down one level in terms of financing? Like, is the business model, is there revenue generation, is there cost recovery, or is it fully sort of donor funded?
Yeah, for us, it's the latter.
Hey, yeah, I'm working with an NGO, so maybe slightly different structures to others on the panel. I think our model is more around like democratization of mapping as an approach, and the fact that this is just so significantly cheaper than a lot of alternatives. So we have kind of like a few different revenue streams, but kind of a project to, like a contracted project to kind of create data in a certain area is one of them. The kind of advantage of doing it via kind of a low-tech community-based methodology is just that it's significantly cheaper than your alternatives. But we do also try to kind of make our tools and kind of capacity to support other people to use those tools totally free. So like, for example, HOT never charges for any data at the point of access, responds to a request from anyone, anywhere in the world. And that's really important because like in the time of a disaster, you can't unlock funding to create maps within that time frame. So for us to continue to be able to do that, we finance that through kind of corporate donor relationships and like foundation grants and things like that. So slightly kind of varied, I guess.
Yeah, thanks for the global partnership. We are non-profit primarily, and that's at the core of what we do. So we rely on partners really to sustain the initiatives, and this comes in two ways. Number one is the catalytic sort of investment that you need to put into an initiative, and then build solid relationships that can then find value in the initiative, and then shift ownership to the users in a way that then allows them to continue sustaining the use of the initiative, and building more relationships that support the sustainability of that initiative. For the Africa Regional Data Cube, really what we're trying to do is to, number one, work very closely with the governments, to build the business case and for them to see the value. And we're seeing very good uptake by government ministries, departments, and agencies. And the way they're investing their resources is actually just time that they're allocating, and the skills and the resources, and they're coming together and mobilizing themselves to learn and to share the resources that are being made available. That partly is what we want to use as a sustainability model. Obviously, the ambition is to get to a point where an entire government can say, we really see value in this, and we want to expand. We want to invest more of our own financial and technical resources in building it up for the country. And the role of the partnership would be then to facilitate access to technological capacity building from NASA, from GEO, and all the other global partners that can come in occasionally, not all the time, to provide the level of support that's needed.
Hi, my name is Malini Modi, and I'm from Department of Environmental Affairs in South Africa. For me, it's not a question, but more of a comment. I've been in the geospatial field for over 18 years, and I'm sure the panel members would agree that one of the problems we actually have is that whenever we go into a project, we never ever take a step back and look at what exists in terms of data. We always try and think that we are the only ones, and this is the first time that we're trying to do something, and we never take stock of what we actually have. And if we actually do that, we will understand that there is much more out there than we realize. And one of the other issues with data and data gathering is that we never ever collect the data at the lowest level and allow it to aggregate to any other level upwards. We always look at what level of data we want, and then we go in and only get that data. Whereas if you take a few steps back and you actually collect the data at the lowest level, it actually will feed into much more of your project and then what we are trying to answer at just that point in time. Thanks.
Thanks. I think we can take one last question.
Hi, so my question is more towards Rebecca, but also to the other two panelists if it applies. I'm curious how you deal with language in your interface when you're customizing to different contexts. And then if this applies to the other panelists too, if you offer your platforms in other languages and how you deal with the data and the metadata.
So in terms of the actual data that's collected, you can collect that in multiple languages and essentially just kind of switch. So I could look at the app in Spanish and you could look in English. And in terms of the apps themselves, they are also provided in multiple languages, but that has actually generally been kind of demand-led. So like someone in a particular context says, can I have this app in this country, in this country, in this language, and then it will be provided. The other thing I think is really important there is especially with place, you encounter, one place that has 8 different names in 8 different dialects, and it also has a government name, and then it has the name of the previous government regime, and then it has a religious name, and all these things. And especially in like health contexts, often the main information you need is just like where do you live? Because if you're getting cholera, probably the person next to you is going to as well. So where is that? And so we also have this kind of like high focus on alternate names. So I can tag like one place as all these names, and then you can use a different terminology to me, but we can both end up in the same place. I genuinely don't think this sort of thing works if you don't do that, because you're able to communicate with a subset of the population. And so it's kind of significantly less usable, and you know, it also involves, for example, adopting one of those schemes which, you know, in official statistics might be the government name, but that's just not what anyone who's actually there calls it. We also have this case which I think other people will be quite familiar with around like redundant POIs. So people would say like that in many countries people identify where they're from as being in relation to a point of interest, but often that point of interest doesn't actually exist anymore. So they'll be like, get to G's garage and then turn left, and then you'll find out that like G's garage hasn't existed since the 90s, but that's still how everyone else calls it, which I think is like an extra layer of challenge in terms of how can you communicate between like different languages and different reference points, even at that level, which I don't think we've got kind of a perfect solution to yet, to be totally honest, but yeah, multiple languages are very, very important.